So friends, welcome to the electricity episode number 2. So here we have to do conductors and insulators and potential difference. So these are the topics we are going to cover in this video. So these are the topics we are going to cover. So let's proceed to conductors. So let's proceed to conductors. So conductors are those substances uh, which can allow electricity to flow through it. Yes. So conductors are uh, those substances through which electricity can flow. Okay, through which electricity can flow. So let's write it so that you will be able to note it. Conductors are substances from which electricity can flow. Now there are lots of examples for conductor. Every metal is a conductor, and carbon in the form of graphite. Graphite is, friends, the tip of pencil. Here I have a pencil. So this tip from which you write, this is made up of graphite in the which is a form of carbon, here you can see. So this is also also a conductor for electricity. So there are lots of examples. Now let's proceed to insulators. Insulators. So conductors are those from which electricity can flow. And what about those? What are called those from which electricity cannot flow? So those substances are called insulators. Insulators are from which, here you can write substances from which electricity can't flow at all. Yes. Here electricity cannot flow, or if electricity will flow, then in a very less amount, which is just negligible. Now what makes a substance conductor or insulator? Now just listen to me closely. Every substance, whether conductor or insulator, have some charges. Some positive charges means some electrons, and some protons and some electrons. So the substances in which the electrons are not fixed means these are free electrons. It can move easily when electricity is passed through it. Then those substances are conductors. So conductors have one more property, that is presence of free electrons. The presence of free electrons makes a substance conductor, and the absence of free electrons makes a substance insulator. Now when let's suppose this is a wire and these are electrons. I'm not drawing protons for easiness. So this is a wire from which electricity is passed. Then all the electrons will. This is a conductor. Okay. Then all the electrons will move in a same direction, like this. Okay. So and let's take a non-metal other than graphite, which is a conductor. Or you can say, just let's take a insulator. Here, when electricity is passed, electricity cannot even pass because the electrons are fixed. Now electricity can also be classified into two parts, which are: number one, static electricity and current electricity. Here you can see static electricity and current electricity. So in static electricity, the charges that I show you here, the charges don't move. The charges do not move. Means the electrons or protons, they do not move, they remain in a fixed position. But in a current electricity, there is this one, which is proportional to the conductors. So the current electricity, which are found in conductors, such as metal and graphite, there the electric charges that are plus, negative and positive charges, electron and proton, can move freely. So this is what electricity is till now, till conductors and insulators. So friends, till here we have done. Now let's go to electric potential. So what is electric potential? So the electric potential at a point, okay, in an electric circuit. So what is an electric circuit? The arrangement of batteries and conductors to pass electricity is called electric circuit. For example, this is a wire. Here is a battery. This is positive. This is negative, and this path follows through a bulb. When electricity is passed through it, when a switch is on, then this bulb lights up. So electric potential is the electric potential at a point in an electric field. Is defined as the work done in moving a unique positive charge from infinity to that point. So let's make it clear. This is a bit fishy. So let's make it clear. Potential. Electric potential can also be said as potential difference. So electric potential can also be written as potential difference. So to understand potential difference, let me make an equation. So the potential difference is nothing but work done by quantity of charge moved. You just have to remember this is not so much fishy. It's just very easy. So the SI unit for potential difference is volt. Potential difference, you can also write it as PD. And the SI unit for work done, as we know it, is joule. And the SI unit of charge, quantity of charge move, is nothing. Quantity of move is, just remove this, just remember this charge. So charge is coulomb. We have studied coulomb in the previous video. So this is what it potential difference. Now if it will be asked, then what is 1 volt? Then you will say 1 volt is 1 joule per 1 coulomb, or you can just say joules per coulomb. Now for solving numericals, you can write potential difference as V, work done as W, and quantity of charge move as Q. So let's make a numerical. So the question is, how much work is done in moving a charge of 2 coulombs from a point at 118 volts to a point at 128 volts. So what are the points we are given? The points we are given is 118 volts and 128 volts. So these are the points which are given. And what more we are given? We are given the charge, that is Q. Here Q, quantity of charge moves, is given as 2 coulombs. Now this is potential difference. We have to take out potential difference. So, and we have to find work done, that is this W, measured in joules. So the potential difference here will be 128 volts minus 118 volt. So the potential difference, or just PD, is equal to 128 volts minus 118 volts is equal to 10 volts. So potential difference we have got is equal to 10 volts. So now let's solve this. It's very easy. So v it's V, that is potential difference, is equal to W by Q. W by Q from this equation, as we know this from this equation, is W by Q, as here you can see is W by Q. V is 10, W is not given, we have to find it, and Q is given, that is 2 here, 2. So what will be W? So very easy, just send this one to the upward here. So work will be 10 into 2 is equal to 20 joules. So this is we have done this, and it's really very easy, not surprising. So meet you friends in the next one.